Laws of logarithms. We know that there are index laws. A logarithm is just another way of looking at an index, so it's perhaps not surprising that there are laws of logarithms. There are various laws of logarithms, and unsurprisingly, they are all derived from properties of indices with which we are all familiar. Note in all of the expressions below, a, x, and y are all positive, and a is not equal to 1. So, law 1. Log to the base a of m times n is log to the base a of m plus log to the base a of n. And note, you'll be expected to work this in either direction. This first one I'm going to actually derive. So if we let x be equal to log to the base a of m, and y be log to the base a of n, using the equivalence of log and index statements, we can say that m is equal to a to the power x, and n is equal to a to the power y. So mn is a to the x times a to the y, therefore mn is equal to a to the x plus y, using an index law that we know well. Then if we use the equivalence again, this time in the other direction, we get log to the base a of mn is x plus y. From above we know that x was log to the base a of m and y was log to the base a of n, so finally we get the law. Now these log laws are important, so make sure that you don't just know how to look them up in the formula booklet, but you really know them and have done lots of practice with them. So moving on, we have law 2. Log to the base a of m divided by n is log to the base a of m, take away log to the base a of n. This one is easily derived from law 1 by using the same approach and the fact that 1 over n is n to the negative 1. It's most easily derived, however, using law 3, which comes next. Once again, it's an important law, remember it. Law 3 says log to the base a of m to the power k is equal to k log to the base a of m. So in other words, this power can drop down in front. This law is just law 1 applied repeatedly, with m being equal to n. Log to the base a of m times m would be log to the base a of m plus log to the base a of m, which gives us log to the base a of m squared is 2 log to the base a of m. Just repeat the argument for m cubed, m to the 4, etc. It's induction for those of you who remember proof by induction, so those doing specialist. At least that's the case for positive powers. Law 4. Log to the base a of a is 1. This one is really obvious if we convert to index form. A to the power 1 is a. Law 5. Log to the base a of 1 is 0. This one is also obvious when converted to index form. We know that a to the power 0 is 1. A useful identity which is derived from law 3 is that log to the base a of 1 over b is negative log to the base a of b. So how did we derive that? So we've got log to the base a of 1 over b, which is b to the negative 1, and then straight away From there we know that the power can drop down in front, and then we've got log to the base a of b. And of course we don't need to write the 1 in this situation. It is this very identity that prompted me to write above that law 2 is easily derived once you have law 3. So if we have log to the base a of x, take away log to the base a of y, then applying this, that's the same as having log to the base a of x plus log to the base a of 1 over y, and then using law 1 you just get log to the base a of x multiplied by 1 over y, which is x over y. So it's quite a nice easy one once you have this identity.